Hello and welcome to my channel. So today I'll be solving a question on bearing and distances. A plane takes off from point X on a bearing of 065 degrees and flies 6 kilometers. It then changes direction to a bearing of 136 degrees and flies 13 kilometers to another point. Calculate the plane's final distance from point X and its bearing from X. So here, first of all, let's take for instance that this is the point where the plane starts. So we'll draw our cardinal point and we'll call it X. They say it has this bearing. So bearing of 065 is from north to east. We have south and west. So we have, for instance, something like this, 065 degrees. And then it flies 6 kilometers. So this is 6 kilometers. They say it then changes direction. That means there is another cardinal point here where it changes the direction towards what? 136 degrees. So if we are taking north, east, south, west, 136 should be more than 90 around this position since we are not drawing to scale. So we have something like this, and then this is 13 kilometers should be longer than 6, so let's just extend it a bit. So here we have 13 kilometers. This is the distance. So here the entire place is 136 degrees. So now based on this, if we want to connect a starting point from its top point, we can call this point Y and then we call this point Z. So to stop it, you cannot connect both of them this way. So since this is point Y, I'll call this Y as well, the smaller y. Then let's see how we bring out our value so that we'll be able to solve to find the distance Y, which is the distance where the plane is to its starting point X. So first and foremost, let's find out what is here. So if this is 136 and the entire distance from north to south is 180, so to get this smaller portion, we have to subtract this value from 180. So 180 minus 136 will give us here 10, here 7, here 4, and 4. So we have 44 degrees. So here is 44 degrees. And then looking at this portion, we need to get this portion. Now this portion is alternating this portion, and alternate angles are equal. So if this place is 65, that means this place is 65 degrees. So the total angles here will give you 65 plus 44, which is 109 degrees. So with this value now, we can be able to use cosine rule to find y. Here we have y square is equals to this other side, 6 square, plus this other side, 13 square minus 2 into 6 times 13. Then we have cos the angle opposite the y is 109 degrees. So 6 square is 36, 13 square is 169 minus 2. 6 times 13 is 6 times 3 will give you 18, right? And 8 carry 1, so this will give you 7. Then let's look for cos 109. Cos 109 will give you minus 0.3255 approximately. So this plus this will give you, this one is 5, this one is 0 and 2. Then minus 2 into 78 into minus 0.3255. So let's solve this aspect. This one will remain here. Minus times minus will turn it to plus. So 2 times 78 times 0. This value is going to give us 50.778. So when we add these two together, we'll be having 255.778. Now we are looking for y, not y square. So y will be equals to square root of 255.778. And that square root will give us 15.99 kilometers. So let's approximate it to have a whole number. This is going to be, since all our distances are whole numbers, so let's approximate this. We're going to be having 16 kilometers. That's why. So we have answered the first question. Now the second question is we should find the bearing of y from x, z from x, because this is the stop point. So we'll find the bearing. Now in finding the bearing, let's find other aspects, because when we want to find the bearing of a particular place, in this case z from x, we have to start taking our bearing from north down to the point where the lines from the start point meet the point z. So the problem is knowing this turn. So if we know the turn, that is the bearing. But first, how do we get this turn? We have to, since the entire distance around this point is 360, we have to know this portion and know this portion. Then if we subtract these two portions, from 360, we should be able to have this distance, which will give us the bearing. So starting, looking at this point, we have 44 here, and 44 is alternating this point, so this point is 44 degrees as well. But we don't know this portion, we can call it alpha. So let's look for alpha. Now to find alpha, we use sine rule. Sine alpha 1 over the opposite is 6 equals to this angle, which is sine 109 divided by y, and y is 16 kilometers. So let's make this the subject of the formula. Sine alpha equals to 6 times sine 109 divided by 16 to give you 6 times. Sine 109 is going to give us the value 0.9455 divided by 16. So multiplying 6 times 0.9455, we're going to have the value 5.673 divided by 16. Let's divide that by 16. So we're going to be having 0.3546. But we are looking for alpha, so alpha will be arcsine of the value 0.3546. So which will give you, let's take the arcsine of the value. Arcsine of this value will give you 20.77 degrees. So how do we get this complete value now? Since this value is 20.77, then if we add it with this, 44, we're going to have, if we call this true distance beta, so beta is going to give us 20.77 plus 44, which will give you 64.77. So for us to get the bearing now, the bearing will be equals to 360 minus 64.77. So let's subtract. Let's see what we have. So we're going to be having 295.23 degrees. So it's approximately 295 degrees. So now to finally conclude on the bearing, you will now say it is this portion, this entire portion is going to give you 295 degrees. That's our bearing. So we have answered the second part of the question. Thank you and bye for now.